Farhan, I forgot. Are we having exam this week?
Oh shoot, I completely forgot about that. But I think we have discrete math paper, right?
Yes, we have discrete math paper.
Wait, I think some said that fundamental of logic will be in the exam. I have no idea about that.
I don't know even anything about it. What?
Oh, shoot.
I don't know anything about it, even the basics thing.
Do you think we should call Farah for help?
Yes, I think she can help us.
Hey. Oh, dari jauh dia dengar. Farahin, wait, I was just about to call you. How do you know we have a problem here?
You guys have a problem in fundamental of logic?
Yes, we do.
So guys, I have a video prepared for you guys.
Serious ah?
Really?
Yes.
Walau weh.
Jom kita tengok. Let's watch together.
So, what is logic? So basically, logic is the study of reasoning and arguments. It is a branch of mathematics that deals with the principles and methods used to distinguish correct from incorrect arguments and reasoning. In other words, it is the process of constructing arguments by careful deductions. It involves the use of symbols and form a system to model and analyze reasoning and arguments. And is a fundamental tool in mathematical proofs and other areas of mathematics. So now you know what is logic in mathematics. Now let's jump to some example question and see how to solve these types of question. And that my friend HAFIZ will show and solve one of this question.
Example 1. Given the logical expression not P and Q or P. A. Draw the equivalent switching network for the above logical expression. B. Use the rules of logic to simplify the given logical expression. C. Draw the switching network based on your answer in B. Solution 4A. Draw the equivalent switching network for the above logical expression. So first of all, we start from A, then not P, then it separate to Q or P and ends with B. Next, we have a solution for B. Use the rules of logic to simplify the given logical expression. So the given logical expression is not P and Q or P. So first of all, we apply distributive law, not P to Q and P, and we get not P and Q or not P and Q. Next, we simplify this using inverse law, not P and Q equal to contradiction. And lastly, we apply identity law because not P and Q has an or between contradiction. So finally, we get not P or Q. And this is the solution for C. Draw the switching network based on your answer in B. So A to not P to Q and ends with B.
So how is it? It's not complicated, right?
Yeah, right?
Yes. Like Sejiwa say,
Peanut.
Since you guys know law of logic, I have one video for you guys. It's about how to find conclusion using an infinite method.
Here, thank you so much Hafiz for explaining example number 1. Now let's jump to example number 2. The first one, consider the following arguments. Let's read the question. If Haziq performed well in his job, then he will be promoted. Haziq's supervisor does not favor Haziq. If Haziq is promoted, then his supervisor favors him. So they have 3 questions for this type of question. A. Write the primary proposition using the variables P, Q, and R. B. Write all the premises using the variables in A. And C. Use the rules of inference to find the logical conclusion of the argument. So, this kind of question usually will appear in the final. So, let's start to solve a question number A. So basically, a question A, we actually need to declare what is P, Q, and R. So like this, we can find from this statement the for of P is Haziq performed well in his job. How to know this is the first statement? You can see based on the comma. The comma reference to where the statement is end. So P is Haziq performed well in his job. So next is Q. So how to find Q? We go to the next statement. Then he will be promoted. So as you can see, the indicator to end the sentence is the dot. So this is Q for the second statement. Lastly, R. How to find R? Okay, let's read. Haziq supervisor does not favor Haziq. If Haziq is promoted, which is reference to Q, then his supervisor favors him. So as you can see, supervisor favors him and supervisor does not favor Haziq is actually a same statement. So what we can do this, we can put R is supervisor favors him. Why we don't put supervisor does not favor Haziq? Because for primary proposition, we must put all the statements in a positive way. So the answer should be like this. P is Haziq performed well in his job, Q Haziq is promoted, and R supervisor favors him. So that is solution for A. Next, we are going to jump into question B, which is write all the premise using variables in A. So what we need to do, we need to refer back to A and also refer back to the statement given. So like the first one, P. So for this one, let's jump back. So how to know all the premise? Actually, it's quite simple. What we can see here, as you can see here, every sentence will have a dot. Then we use the dot as a reference to end the statement. So let's start. The first statement is if Haziq performed well in his job, then he will be promoted. So as you can see, there's a dot after the promoted word. So that is include statement number 1. So if you can, based on solution A, Haziq performed well in his job is P, then he will be promoted is Q. So we can just put P to Q for P number 1, for statement number 1. So for the statement number 2, Haziq supervisor does not favor Haziq. So what we can say from this is Haziq supervisor does not favor Haziq means is equal to R, but actually when does not, the keyword is does not, is reference to negative. So the P2 is going to be negative R. So lastly, P3. If Haziq is promoted, then his supervisor favors him. This is referring to if Haziq is promoted is statement for Q, his supervisor favors him is referring to statement R. So what we can put here as a P3 is Q to R. So that is solution for B. And lastly, let's jump to solution C. So to answer C, we must refer back to question A and B. So the first step to do is copying back from the answer B, which is P to Q, not R and Q to R, which is in number 1, 2 and 3. After we done that, what we need to use is we must use the inference of law, which actually this kind of solution is similar to solution for chapter number 1. So what we must to do here is we must to refer the laws that have been given in the discrete math and we must to simplify it. So the first step, what we need to do is determine and find what can be simplified. So from this we can see the statement number 1 and statement number 3 can be simplified as syllogism. So what we must do is we create a new statement, we call it number 4, and write the answer after we simplify it, which is P to R. After we have done that, what we need to do is put the number of the statement that we use. So like for this, for number 4, we use statement number 1 and number 3. So we put 1, 3, and also last but not least, we must put the laws that we use to make sure we remember what the law we use, so we don't get confused when we do for the next step. Once you get that done, we left with number 2 and number 4, which is not R and P to the R. So for this, we can use modern tolerance as a law to simplify it. So the answer, we create a new statement called statement number 5, which in this statement we put the number of column, which is 2 and 4. Once you get done, we put the name of the law, which is modern tolerance. After we have cut all the statement and left it in only one single statement, which is a number 5, we can conclude it. So for this, the conclusion is, therefore the conclusion is not P. Haziq does not perform well in his job. So this is the solution for question C.
Gitu. Not so hard, is it?
Not so hard lah.
Fundamental of logic?
A confirm.
Hey,
Darwish!
Yo.
Wait, I was glad you're here.
Oh.
Well, I'm stuck in this question. I have problem with this.
Oh really? Oh, I thought you already watched Farah show my video and Hafiz.
Yes.
Oh, but you start with this?
Yeah, I'm still stuck with this.
Okay, let me help you with that. Okay, so how to solve this question, like Iman said. So basically, this question can be said as one of the easiest question that can be found in fundamentals of logic. What the method that we can use is we can use method of inference. So how we do this? Basically, like in the video that you already watched, the things is pretty similar. The first one, we must to identify these 3 of units. So let's assume P to Q as a P1. So we name it P1 is equal P to Q. Alright. So next, R equal to not Q. So we name it P2 is equal R to negative Q. And lastly, the single R as P3. So once you've done that with that, so what you need to do is we need to identify this. So how to identify this is pretty simple. First, you must to know what is laws of inference. For me, that already master of this topic, we can master it by remember the laws of it. So first thing first, we must to identify. So as you can see here, I can take out P2 and P3 using a model exponent. So I cut it out and make it as a P4, which is going to be a not Q, or I can say negative Q. So we name it model exponent to remember what is the law that we are using. So after that, we name it, we call it the row, like this one P2 and P3, so just put it 2, 3. So you also can understand what are you writing right now. So after we done that, as you can see, we left with P1 and P4. So we can still cut it. So how? So for this one, we can use the brother of modern exponents, which is modus tollens. So we name it as P5. So how we do this? Basically, modus tollens, we just cut it left bit with negative p, and as usual we name the law modus tollens, and we put the name of the row, the number of the row, which is p1 and p4, 1 and 4. And as you can see, there's no p left, only the p5, so we can conclude it as this question is, the answer is not p. So that is how we solve for this kind of question. Very easy.